Multiplicity. This represents the number of times that a zero or an x-intercept may occur. Multiple means more than one, so we're going to focus primarily on zeros that occur more than one time, even though you can have a multiplicity of one, which really doesn't make any sense, but you can. So what we're going to do is do these examples and then take a look at the graphs to give you an idea of what might be happening. So take, for example, f of x equals x minus 2 squared. Now this can be rewritten as x minus 2, x minus 2, because of the exponent 2, which means you have two x minus 2's, which means you can set both those equal to 0, but I really only need to set one of them and solve for x to find the 0, because if I were to do the other one, I get the same thing. What that means is that x minus 2 is a factor that's occurring twice, which means x equals 2 is a 0 that occurs twice, and that's why we say that x equals 2 has the multiplicity of 2. So we'll say x equals 2 with, look at the handwriting, that's atrocious, with the multiplicity of 2. That's how you think of it. Now this one, x plus 4 cubed, we'll just take the x plus 4, set equal to 0, subtract 4 from both sides, we get x equals negative 4. That one has a multiplicity of, that's correct, very good, 3. As you can tell, it goes by the exponent. By the exponent, if you were to write that out, as be x plus 4, x plus 4, x plus 4. If you were to solve the 0, you get x equals negative 4, multiplicity of 3. Now let's just take a look at the graph of each of these. Now x minus 2 squared is a parabola. It's like a touch and go. It hits the x-axis and takes off again. So an even, this is for even. If you see an even exponent, because that represents the multiplicity, the graph will look something like that. You can change it to x minus 2. I can't get it to the fourth if you want to, and see it looks similar. See that? Now let's look at x plus 4 cubed. X plus 4 cubed. When I graph it, it actually thinks about going to a touch and go, but it doesn't. It takes off again. So it'll look something like that, or something like that. It's not. It's almost a touch and go, but it takes off. So it passes through it. So let's look at this last example. And if you see this last example, which hopefully you do see it, I have two unique factors, so I'm going to set those equal to 0. I'm going to solve each of those. Now x equals negative 3, since it has the exponent of 5, that's a multiplicity of 5. And it probably looks something like that. Something like that. I don't know why I do that. I put this 4 there. Why did I put a 4? I don't know. And then this x minus 5 equals 0. I'm going to erase that because it's bothering me. Is it bothering you? Yeah, it's bothering me. So when I add 5 to both sides, I get x equals 5. And that has a multiplicity of 4. So that's probably either that or that. So let's just go ahead and just graph it. Take a look at it. X plus 3 cubed, x minus 5 to the fourth. Let's graph it. Okay, that's something of what we would expect. It goes through the x-axis at negative 3. And it looks like it's a touch and go, not for sure, but it looks like it is. You can always zoom in just to make sure. Zoom to, and then we're going to go over to x equals negative 5. Or positive 5, I mean. And just hit enter. Yeah, that's what we're expecting to see. So this can be really handy. These multiplicities can be when it comes to actually graphing or choosing the correct graph. If it's an odd, it goes through. If it's an even, it's a touch and go. Things to keep in mind.